matching algebraic expressions. Technically, we kind of already did this. However, we didn't do the evaluating. So that's why we're going to go through this. A little more practice isn't going to hurt. Our basic goals: writing algebraic expressions for real-world mathematical situations, matching algebraic and verbal. So that's our translation between English and math. Identify parts of an algebraic expression using mathematical terms. So we're going to do several vocabulary words today. I'll apologize in advance. We didn't get the vocab sheets done yet, and we'll get them to you. But we're just going to at least highlight them in the books today. And then we're going to learn how to evaluate expressions at specific values. Our first part, we're going to determine the product, sum, difference, or quotient. You've only got 4 to do. This should take you all about 2 minutes. Do it by yourself, and then you can compare answers with those at your table if you wish. Go. Okay, our first one should have been really straightforward. Multiplying a fraction times the whole number. What's the first thing I need to do? Put 1 under the 28. I need to have them both as fractions. Now you can either multiply across. Personally, I like to look for reductions. I know I can divide 4 out of both of those. 1 times 7 is 7. 1 times 1 is 1. 3 times 7. Second one, straight up. 6 plus 14 just means I'm adding 6. Gives me 10. Carry the 1 gives me 20. Okay. Unfortunately, number 3 caused a lot of issues. Do we have a commutative property of division? No, we do not. My order matters, doesn't it? So the easiest way to do this one would have been to turn it into a fraction. And I turned it into a fraction. 4 divided by 12, right? Which I can simplify that. Gives me 1/3. So I divide them both by 4. Or if you wanted to do the actual math, that is 4 divided by 12. Will 12 go into 4? No. So I add a decimal and a 0. 12 goes into 40. 3 times. Gives me a 4. Anybody notice something? Keep going on forever, right? So what do? A line. Is that the same as 3?
No.
No. A lot of you answered 3 to that problem. You cannot do 12 divided by 4. That is a problem. You must have the correct order in division, guys. Same thing in subtraction. It must have the same order. So I do 13 minus 7. Gives me, I can't do that, so I got to borrow. Gives me a total of 6. Everybody understand what happened on these?
Yeah.
Okay. It's going to be a lot about mathematical terminology and making sure we are being accurate and speaking correctly mathematically. Got it?
No.
What number? No, the answer is 3 times repeating brother. Okay. Guys, please stop the chatter. So, for number 1, what is the math term for 7? What do we call that?
The division number
For number 1. 7 is what? What's the math term for that? Product. If I'm doing multiplication, my answer is the product. For number 2, what is the 20? The sum. For number 3, what is the 3 times repeating? Quotient. For number 4, what is the 6? Different. You have to understand those terms, guys. Okay? Yeah? Not really. I mean, if the direction said to, you could. But if you rounded it, actually rounded 3/10, not round up. So again, your terminology, be very specific. Your terminology worries about that one. And it would be 0.333, right? So if I round it, actually be 0.3. 3/10. Make sense? Okay, I hope so. Now, we already practiced this. Let's see if you guys remember. We're going to rewrite each statement using symbols. In other words, I've given it to you in English. I want you to write it in math. So I want you to solve it. No, I don't. I just want you to write it. So you're going to rewrite each expression using math numbers, math symbols for 1 through 10. If you guys are like last class, you're going to miss close to half of them. because you're all forget about flipping phrases. So only thing I will warn you on. So I'll give you 4 minutes, because all you're doing is writing the expression. Because it actually is important, mostly because we don't have commutative properties in division and subtraction. So if you don't have the correct orders on those, you're going to get them wrong. But the whole idea of this exercise is seeing if you can translate something from English into math and do it accurately. Then you really got to pay attention to our flipping phrases especially. So when I say 14 more than 6, what number actually comes first? 6. Because it's 14 more than that, right? So technically, if you wrote 14 plus 6, you would get the same answer. But the way this is written, this is what it should look like. Okay? Our second one is 6 more than 14. We changed our order, didn't we? So now it should be 6 more than 14. 7 less than 13. This one, you only have one choice. It has to be 7 less than 13. 7 minus 13 is going to give me -6. Completely different answer. 23, subtracted from. That's another one of those flipping terms. 30 means that it's 30 minus 23. The quotient. Quotient means what? Technically the answer to a division problem. So it tells me I'm going to be dividing 12 divided by 4. That's actually the first one that is straight up the way it's written. The quotient of 4 divided by 12. So now I'm switching it. Does that matter? Yeah. It's a completely different answer. You must have it written the correct way. Now, in both of these cases, if you had written them as fractions, that would have also been acceptable. And just for the record, that's one of those few instances where you would not have to simplify. Asking for specific numbers, you would leave it in that form. Make sense? Now, this one gets really tricky because what does that word of mean? What operation is that? Multiply. So this is actually a multiplication problem. What am I doing? 1/4 times 28. That was actually in your opening exercise. That's how that one needs to be written. 2 to the 7th power. We talked about the exponents. All that is saying is an exponent. 7 squared, we talked about that one as a special exponent of 2. Then our last one, 2 times the sum of 4 and 6. What am I doing on that one, Ben? Okay. So I need to put a time symbol. If I put a time symbol, you're okay, as long as you did a time symbol and not a variable. If you did a variable, that would be wrong. So that would not cut it. Can't do that. That's a no-go. Okay? Huh? 4? There you go. Any question on this page, Brantley?
Is it square just multiplied by the
It is, but where does it specifically say at the next level? So if you wrote it as 7 times 7, you get the same answer, but because it said squared, that in math language, that's telling you I'm using an exponent. Okay? So again, those are equivalent expressions, but what was written in English is modeled mathematically by 7 squared. Make sense?
Yeah.
Sure. Okay, let's go to 361. A school lunch costs $3 for each student. For each situation, write a numeric expression to determine how much the school collected, then evaluate the expression. So there's 2 parts. Part 1, I'm going to write an expression. Second part, I'm going to then evaluate or solve it. Okay? So we'll do one together, just to make sure everybody understands what we're doing. So I have 55 students purchase a school lunch. So how would I write that? 55 times 3, correct? So then to evaluate, now I actually do the math. So I do 55 times 3, 15, 165. So the school collected $165. Make sense? Okay, so you do that for parts B and C. And then I want you to try to do part 2, write a sentence to describe how you can determine the amount of money collected for any number of students buying school lunches. In other words, just tell me what you would do every time. So we'll go to that point. I'll give you guys like 2 minutes. Okay, the second one. Now we've got 126 students to purchase. So I'm going to go 126. Each one costs $3. So to do the math, 126 times 3 gives me 18, 7, 378. Yeah, that's right. So the school collected $. And then our next one, 1,512 for just a school lunch. So 1,512 times 3. We do the math on that. 1,512 times 3 gives me 6, 3, 15. So the school collected $4,536. Okay. So who can tell me the sentence you put together to describe what we did? Andrew? Good. Excellent. So take the cost of the school lunch $3 in this case, and multiply by the number of students. So hopefully you guys noticed as you did these problems, did the 3 change in any of the problems? No, what changed?
The
Number of students. So in question 1, there is one quantity that changes or varies, the number of students who bought school lunches. So in math, we can often use letters to represent quantities that vary. These letters are called variables. Go ahead and pull out your highlighters, and I'll apologize up front. We didn't get you guys the vocabulary for this module yet. We will get that to you probably next week. But one of the first ones you're going to see is an algebraic expression, which is an expression that has at least one variable. So when I put a variable into an expression, we now refer to that as an algebraic expression. If we were to write an algebraic expression to represent the total amount of money collected for S students buying school lunches, and just as a hint, guys, especially a lot of these early on, a lot of times we will use the first letter of what we are using as our variable to help us mentally put together what it is we're talking about in our equation, right? So normally the way we would write this is we would make a little key and we'd say that S equals the number of students to define our variable. I'll be honest though, S is not one I would ever use as a variable. Anybody want to guess why? Because if I do an S, and if I have sloppy 5s, they will look a lot alike. There's a couple other ones I wouldn't use as variables. Another one I wouldn't use as a variable is an O, because what does an O look like? Looks like a 0. If I use a small case L, what does that look like? A 1. which is why when we were doing our area formulas, that when we used L, we always used a cursive one, right? Does that make sense now? For those of you that didn't connect that. So there are certain letters that we use. The most common one we use for a variable is X. Okay? Welcome. Now, why is that? Let's go back up here. Because there are multiple ways to write multiplication. So, historically, from elementary school, that's what we've done, right? Technically, it's okay. The problem is we're really getting into our algebraic expressions now. That's why Miss McCann and I have been working so hard with you, trying to get you to switch to this. Right? That's the biggest reason, because now that we're getting into variables, that's actually a multiplication. That's saying I'm doing 3 times the quantity x, which is one of our most common variables. If I'm using this symbol, that gets really confusing. I'm doing a variable and a constant variable and constant, or am I trying to say multiply? The other one that we've done some of, especially now that we're doing order of operations, is parentheses. You guys should all include this in your notes up at the top of this page. Make sure you're writing down all the different ways we are showing how to multiply. Got it? What? It does, but now this means I'm doing 3 times some unknown quantity x. And then if I give you a value of x, you'll know what to multiply by. The first way here, now it looks like I'm saying I'm multiplying 3 times some quantity x times 5, or 15 times that quantity x. It's completely different. Okay? Which gets to our next definition. So our next definition is coefficient. Coefficient. A coefficient is what we call a number multiplied by a variable in an algebraic expression. If my coefficient does not appear in front of a number, it is understood to be 1. So, and this is where it gets a little nitpicky, but it's actually really important to understand. So I'm going to take a minute to go through this. When we are writing an algebraic expression for S students, how would I write that? What did you guys put down? Anybody do this number 3 yet? And did you do number 3? No. That one? Thanks for being honest. Okay, if I have some S number of students that are buying lunch, how would I figure out how to find out how much money is collected? What do you think, Bentley? S times 3. Is everybody okay with that? So is that how I would write it? Could do parentheses, or the way we just said, if I have a coefficient in a variable, I can do that, right? Does it make a difference which way I do that? Yes, it does. It really does, especially now that I put a variable in there. Because I put a variable in there, it completely changes how I must write this. And it gets back to what multiplication means. What does multiplication mean? What is the actual operation of multiplication mean? In addition. So how I write it is actually important. Because if I write, for example, 3 times 4, if I'm going to model that, what would I actually do that as repeated addition? How would I write that? 4 plus 4 plus 4, right? Because the first number is telling me how many times I'm adding the second number by itself. So if I did 4 times 3, how would I model that? Shut. Excellent. So I'd say 3 plus 3 plus 3 plus 3, correct? Somebody understand that? So even though the answer is the same, the way I write it changes what I'm actually doing, correct? So now, given this thought process, if I come here and I say S times 3, what number is it that I'm repeatedly adding? 3. So to model this, how many times am I going to add 3? I don't know. But I don't know. So can I model this? No. Can I model this? Yes, because what am I adding to itself? S, how many times am I doing it? 3. So can I model this?
You don't know what
Just did.
Oh,
Can I answer it? Evaluate. That's how I know it. Or can I model it? Yes. Can I model this? No. So can I write it this way? Is that okay?
No.
No, it is not. That is not mathematically acceptable, guys. That's the whole idea behind this coefficient. So in this term, my coefficient is 3. That's the number that comes with it. My coefficient must always come before my variable. Nobody understand that? In an algebraic expression, a multiplicative algebraic expression, my coefficient must always come before my variable. Why? Because it's the only way I can model it. It's the only way it makes sense mathematically. Now, sometimes you're going to see just a variable. So if I just have an x, what's my coefficient? 1. Because what is 1 times x? X. Doesn't matter what x is. 1 times 5 is. 1 times 10 is. Doesn't matter what x is. No. So I know it's always going to be whatever it is. So mathematically, that's one of the shortcuts we take. If it's a coefficient of 1, we don't write it. So, but if they ask you what the coefficient is, you should know that it's 1. It's just saying it's 1 times whatever that is. Got it? This one here, the circle? Yeah? As an exponent, no, that's totally different. Because when I did it as an exponent, then it's saying I'm multiplying 3 by itself S number of times. Make sense? Because it's a completely different operation. If I do this, that is 3 times 3 times 3 for whatever S is. So S number of times. Instead of adding. That's the difference between multiplication and exponent. Does that make sense? Any questions on this? Okay, so for number 3, I kind of already gave away the answer. We said it's 3 times S. What is my coefficient? 3. 3 is the coefficient. So I got kind of technical a lot on that page because it actually is really important mathematically that you understand why these things are in place. Any questions on anything we just covered on that? Is it making sense? Okay. Gonna go to our next page. The cost to rent a rink is $250 for a 2-hour party. The cost will be shared equally among all the people who attend the party. For each number of attendees, write a numeric expression to determine how much each person will pay. Then evaluate the expression. There's 2 parts. So first, write me an expression. How would you find the answer? And then evaluate the expression. So we'll give you guys about 4 minutes. If you knock those 4 out, try to do part B as well. Okay, what operation does that tell me I'm doing? So whenever you're doing division, there's 2 parts to it. What am I dividing up into how many pieces? So what am I dividing up? The cost of the rink, which is 215. How am I dividing it? By how many people there are. So my expression should look like that. So then I need to evaluate it. So how much is he paying? $15. My expression now changes because my number of attendees is changing. Has my price changed? No. It's still 215. 215 divided by 215 means it's costing them each $1. Now my number of attendees changes to 10. Now I'm only dividing among the 10 of them. So my cost is $21.50. Make sense? So now to write an algebraic expression for this, what was I doing each time? For the number of people P, I was taking 215 dividing by P, or if you wanted to write it as a fraction, that would also be acceptable. But that's all you need to do. So we do the next one together just because we're running out of time. But Jimmy has 300 credit cards to use at the arcade. Complete the table to determine how many credits remain on each card after playing games at the arcade. So if I've got, here's the 3 different cards, each has 300 credits, right? Yeah. So he takes 33 credits off the first one. How would I find out what remains? Subtract, right? So if I do 300 minus 33, I get 267. On the second card, we started at 300. What am I going to do with 57? Subtract. So if I subtract that, I get 243. And then our third one, he does 77 credits. So I'm going to subtract, which is going to give me 223. So if I were to write an algebraic expression for that, what would I be doing? For the number of credits C, what did we do each time? Did I take 33 minus 300? No, I did what? 300 minus, but now we're saying C. Make sense? Okay, go to our next page. Write an algebraic expression to represent each situation and identify the coefficient. So I want to see if you guys can do this by yourselves. There's only 4 of them to do, but we're down almost no time, so I'm only going to give you guys 2 minutes. So do your best. A lot of people are really struggling on this one. Huge, really big. And every single person I saw that is struggling has the same thing they did not do, which we have been stressing since day one in this class, which is marking your text. Guys, if you'll mark your text, it's going to make it a lot easier to translate because you're pulling out in English the words that are important mathematically. So please, I can't beg anymore. You guys have got to mark your text. As I go through here, Ben is selling tickets to the school play. How many will he have left? If he starts with T tickets and sells 125. So if I'm starting at T, I'm going to have 125 left. I'm selling them. What operation is that going to be? Subtracting. Where did I start? Did I start at T or did I start at 125? T. So I started at some number T and I sold 125. Right? Can you see how marking the text will help you on this? Now, we also need to identify our coefficient. So, where's my variable? Because I know by definition, a coefficient is the multiplicative piece of an algebraic expression, meaning I need a number and a variable. So, focus in, where's my variable? T, what number is with it? No, what number is with my T? What's it being multiplied by? No, that's being subtracted. What's T being multiplied by?
7.
Ava? 1. If I don't see it, it's 1. So the coefficient is 1. Remember, if I don't see a number with my variable, that means the coefficient is 1. It is always being multiplied by something. If I don't show it, it means it's a 1. A plane descends to 5/6 of its circulating altitude A. What is the new altitude? Why did I underline of? What does of mean? No. What does it mean? Multiplication. So it's telling me it's multiplying, right? So this is 5, 6 times 8. What is my coefficient? No. Got it? No. Not 1. 5, 6. You did not say it. You said 1. The coefficient is 5, 6. Got it. When I'm writing a variable and whatever I'm multiplying it by, that is what a coefficient is. So if it's a fraction and decimal, it doesn't matter. What I'm multiplying it by is a coefficient. Game downloads cost $6 each and with an additional membership fee of $10.75. What is the cost of X downloads? So this one gets a little more complex. What is being done every time it's done? How much is that? 6. But if that's my only cost? No. What else? What other costs do I have? Do I do that every time I download? No. So how do I put those two together? Yeah. Can't eliminate it. That cost has to be paid. Now, you press enter on what? No, because that's going to put them together, saying I have to do both of them every time. And what operation? Good. So those are big catches. And I said, well, I'm doing that X $6 every time, right? But then I need to add the 1075 that I have to do once. So what is my coefficient? No. No, X is my variable. My coefficient is the number that is multiplying the variable. 6. So the coefficient is 6. And our last one. Headphones cost $35. Portable music players cost $75. How much does it cost to purchase X headphones and Y portable music players? So what does each headphone cost me? 35. So what operation would that be? Multiplication. How much does each portable music player cost? So what would that operation be? Multiplication, because I'm doing it every time. To get my total cost, what do I need to do those two? Add them together. So I actually have two coefficients. 35 is X coefficient. And 75 is Y coefficient. So I actually have two coefficients in this one. Questions on any of those? Okay, unfortunately, due to time, we got to do this last part together.
Yay! Oh,
We only have 5 minutes left.
fun.
Okay, we do have another definition. This is a really important one, guys, because we're going to use this a lot. And it is the definition of term. Term is of an algebraic expression is a number, variable, or product of numbers and variable. There's a lot of different things that we call terms. If I were to have an expression such as 3x plus 4y minus 7, there are 3 distinct terms. I have my first term, 3 multiplied by x. I have my second term, which is 4y, so 4 multiplied by the variable y. And I have a third term, which is what we call a constant of 7. It's called a constant because it is a number by itself. Okay? So when I look at these, if I have two algebraic expressions, 8 plus 5x and 8 minus 5x, the same, I have two terms in both of them, right? I have a term of 8 and a term of 5 times x. So there are two terms in both, and it's the same too. The difference is the operation, which is going to get you a completely different answer. So if we look at this, identify the number of terms and then the terms themselves for each of these. How many terms do you see in part A? Should see 2. So I have 2 terms. I have 4 and I have 3x. And the second one, I have 3 terms. Although we'll get to the point where you realize there's actually only 2. But as it's written, their 3 terms are 4a, 9, and 3a. And then in our last one, we end up with 4 terms. We have 7b, 9x, 3a, and 12. So when we say the word term, we're just saying one of the pieces to put the expression together. Does that make sense? Okay. If I have a coefficient and variable go together as one term. Since that's how many times I'm using this one. Here's our last part. Okay. And we have one more definition, evaluating algebraic expression. To evaluate means to determine the value of the expression for a given value of each variable. In other words, I need to tell you what my variable equals to be able to solve it. The way I normally do that, I'll give you the expression and then I give you a value. What you need to do is then take this value and place it into the expression exactly as it is. So when I write them side by side, that means multiplication. So I'm doing 3 times 10 minus 4. Now I must follow my order of operations, meaning I have to multiply before I subtract. So to evaluate, that would actually equal 26. Same thing on our second one, but now C is 8, so it means I'm going to put that value in. I'll rewrite the expression given the substituted value. This one's easy because they only gave me 2 terms. 10 minus 8 is 2. Our next one gets a little more complex because now I've got 2 terms, but one's a whole number, one's a fraction. So you guys have to listen to the video to get the help on the homework. Sorry. Okay, so anyway, on this one, we would need to simplify this one first. So I divide both those by 2 to make it 1/2. 5 minus 1/2 is going to leave me with 4 and 1/2. Or if you wrote it as a decimal, we would take that as well. Either one would be acceptable. The next one gets a little more complex as far as the order of operations, but the actual substitution is the same. So I do 5 times 20 plus 1. Now I again follow order of operations. I'm going to do 20 plus 1 first for 21. Now this becomes a multiplication problem, so that equals 105. On our last ones, again, I just substituted into the value, so that becomes 8 squared over 4. Don't forget that an exponent means adds actually 8 times 8, so which equals 64. And then I'm going to do division, so I divide it by 4, and that becomes 16. And our last one, again, substitute the value in. 11 minus 2 to the 3rd power. Remember, that again, the exponent means I'm multiplying it by itself that many times. So I'm doing 2 times 2 times 2. So that's the same as 11 minus 8, which is going to give me a value of 3. Since I don't have kids anywhere, I might as well go ahead and do this one. So now, again, now they've given me a value of h. So I'm going to substitute the h into my expression. So I'm going to do 3 times 2 minus 2 gives me 6 minus 2 for a value of 4. 7/3. Well, it doesn't matter what the number is, even though it's the math gets a little more complex. So 7/3 times 3 minus 2. So I'll put that over 1. Those go away. So that gives me 7 minus 2, which would give us a value of 5. And then our last one, we do 3 times 5 and 1/10 minus 2. So I'm going to do the multiplication first. gives me 15 and 3/10 minus 2. I subtract that and I get 13 and 3/10. Okay. And our next one, again, doesn't change. All I'm going to do is substitute that value in. So that becomes 2 times 1 divided by 3 plus 1, or 2/3 plus 1, which becomes 1 2/3. Then I do the 2 in there. So 2 times 2 divided by 3 plus 1 gives me 4/3 plus 1. 4/3 becomes 1 1/3. Plus 1 gives me 2 1/3. And then I do 2 times 5 over 3 plus 1 gives me 10/3 plus 1. 3 goes into 10 3 times, with 1 left over. So 3 1/3 plus 1 gives me 4 1/3. Hopefully that one was pretty easy for you guys. We didn't do this one, but going straight into the whole word. Our first part, writing algebraic expression representing situation. You have 7 folders and you want to put the same number of pages in each folder. So that should tell you that my division will be my operation. So you need to make sure, yes, you have total P pages. So I'm going to divide the P into those 7 pages, figure out how many pages are in each. Okay, evaluate your expression for 147 or 245. So I've got 2 different ones I need to do. Our second one, you have a coupon for $5 off your total bill at Meals on Main. How much will you pay if the bill would be dollars? So in other words, just do a substitute, write an algebraic expression on that. And then you're going to evaluate the expression for 2 different bills, $23 or $54. You have already read 2.5 hours for the readathon. How long will you have read if you read an additional 8 hours? So remember where you're starting. Addition means I'm going to add, and then we're going to evaluate the expression to read 3 or 5.5 additional hours. In other words, take the 2.5 and add them to it. On to the back page. Write an algebraic expression. So all we're doing is changing. We're doing that translation piece again. Pay attention to your flipping phrases. Also make sure you're very clear about any commas or separations to show the difference in those. And then we're going to identify the number of terms and then the terms themselves. So that was the part we kind of ran through right towards the end of class. Tell me how many there are and identify what those terms are. And then our last part, and this was the part, hopefully, first period we made, second one we didn't. Evaluate each expression for the given value. So I'm just substituting this value in for the variable following the order of operations. Good luck, guys.